In this video, we're going to talk about symmetry. The idea of symmetry is that you could take a shape, a heart would be a good example, and you could divide that shape into two equal parts. In the case of a heart, we could draw a line down the center that would divide that shape into two equal parts. Another viewpoint that relates to symmetry is the idea of reflection. If we were to reflect this shape over this line, the right-hand side of the heart would reflect over to become the left-hand side, and the left-hand side will reflect back to be the right-hand side. And so by reflecting it over this line, we would have the same shape, and that also indicates that we have some symmetry. I always like to think about Fruit Ninja when I'm talking about symmetry. So you think about slicing it right on that line and having the two equal halves on either side, right? And that's going to indicate symmetry too. We're going to look at three types of symmetry together. The first type is symmetry over the y-axis, and the parabola is the best example for that. We could, the y-axis here would be our line of symmetry. So the y-axis divides this parabola shape into two equal parts, and so we could say it was symmetric. When we do this visually, we're seeing mirrored points on either side of this axis of symmetry, or this line that we're slicing on. Okay, and so that indicates that the shape is symmetric. When a graph is symmetric over the y-axis, it is also called an even function. And that is the case for a parabola. In general, if you have a polynomial where all of the exponents are even, it's usually going to fit this type of symmetry and be called an even function. A second type of symmetry that we'll look at is symmetry over the x-axis. And so a parabola sort of on its side has this equation in this graph. And I think you could see that we could slice this shape in half horizontally on the x-axis. And that would divide the shape into two equal parts. And in the same way, we have mirrored points on either side of the x-axis that are reflections of one another. If you performed the vertical line test on this shape, think back to that for a second. Because of these mirrored points, this graph will not pass the vertical line test. So something that's symmetric over the x-axis is actually not a function. Okay, both of these, the y-axis and the x-axis, involve symmetry over a line, or reflecting over a line. There is a third type of symmetry that we'll look at, and that's symmetry over the origin. Y equals x cubed is the simplest example of this, I think. And this kind of symmetry is a little bit different. So in this case, we are actually rotating our shape 180 degrees around the origin, or the point 0, 0. So this is a rotational symmetry. Essentially, that means that we could rotate our shape, turn it completely upside down, and we would see the same picture. So rather than doing a reflection, we could do a rotation here. And I think you could see that would happen with this shape. The right-hand side that's going up would rotate down to be the left-hand side. And this left-hand side that's going down would rotate around to be the right-hand side. So this has symmetry over the origin. This also has some mirrored points, but they're kind of organized a little bit differently. We have a point here on the left that would have a negative x value and a negative y value. and it would be a mirror of a point on the right hand side that had a positive x value and a positive y value. And so those would be mirrored, not mirrored sort of almost diagonally, but they would rotate around to be in each other's place as we did that. So this is called symmetry over the origin. A function with this type of relationship is called an odd function. Now we are going to be focused only on the visual test to decide what type of symmetry we have. There is a test that you can perform on the equation where you exchange x out for negative x and y out for negative y. We are not going to be discussing that in detail, but that is something that exists that you could test the equation for symmetry as well. I hope that gave you a basic idea of the idea of symmetry. Good luck practicing this. Find some graphs that you can test yourself with these three types on.